All right, so what I'm going to show you how to do in this lesson is how to do some division problems a whole lot faster than we've been doing them using long division. We're going to use a method called synthetic division. So before we do it, we're going to write out the steps that we're going to follow, and we're going to also have to make a note of when it is that we're allowed to use synthetic division. So when we use synthetic division, the first thing we're going to do is line up the coefficients of the dividend. So that's our numerator. So we'll write them in a straight row across, just like we would with long division, except without the x's. So we have a 1x cubed, we have a 6x squared, we have 11x to the first, we have a 6x to the 0, or that's our constant. All right, the next thing that we're going to do is we're going to make what's kind of looks like a division bar, but it's upside down. Okay, so step 2 is we're going to negate the b value, which here would be our plus 4, and we're going to place it outside, so it's going to go right over here, -4. So what we're going to do is when we start actually evaluating this using synthetic division, we're going to go through a number of steps. Step 1, we're just going to bring down the first coefficient, so let's list that here as well. Okay, so that's going to be the 1, comes down there. And then we're going to repeat a process of multiplying and then adding over and over and over. So what I mean by that is I'm going to multiply this 1 times 4, or -4. And 1 times -4 is -4, and I'm going to put that there. And then I'm going to add these two terms. So 6 plus -4 is 2. And then I'm going to multiply 2 times -4, which is -8. And then I'm going to add, and then I'm going to multiply, and then I'm going to add. All right, so that finishes the process there. And what I've just created is the coefficients to my quotient. So a couple things that we want to notice here. If the dividend was a cubic and the divisor was a first degree polynomial, then our quotient must be a quadratic. And the reason that is because if I divide a cubic by a first degree, I end up with an x squared, right? Same base, I subtract the exponents. So what I can do here then is I can say, if these are my coefficients of my quotient, then this must be the coefficient of my x squared term. So that must be a 1x squared. And that must mean that this 2 is a 2x to the first. And then this 3 is my 3x to the 0, or my constant. Which leaves me with my remainder, which is -6, and we know that we need to write our remainder over the divisor, x plus 4. So when we did this, we ended up discovering that the quotient here was x squared plus x plus 3, and we end up with a remainder of 6 over x plus 4. And the first couple times you do this, it's going to be new, but then you're going to realize it's so much faster than doing long division. The thing is, you can't do this all the time. Sometimes you do still need to use long division. So let's first identify when it is that we can use synthetic division. So you can only use synthetic division if the divisor, meaning what we're dividing by, is linear and has a lead coefficient of 1. So in this case, we can do that because the divisor here is linear. This is a linear function, and it's a 1x, not a 2x or a -6x. It's a 1x plus 4, so we can use synthetic. So over here, we can also use synthetic because we're dividing by a linear divisor with a lead coefficient of 1. So let's use synthetic division over here as well. Make sure our steps are on the screen here. All right, step 1, we're going to line up our coefficients. So my coefficients in this case are a 1x to the 4th minus a 4x cubed. I am missing an x squared term, so I'm going to hold its place with a 0. And then I have a 5x to the first, and I'm also missing my constant, so that's also going to be a 0. Remember, whatever terms you're missing, you want to hold those places with zeros. Okay, so I'm going to set this up. I'll take my b value and negate it, which only happens with synthetic division. Remember, with long division, you don't negate that b value, but here we are going to. And then I'm going to start my process. Bring down the 1, and then I'm going to multiply 1 by -1. And then I'm going to add -4 and -1. and I'm going to multiply -5 and -1. Then I add, then I multiply, then I add, then I multiply, then I add. Okay, so I started with a 4th degree polynomial, and I divided it by a linear polynomial. So this will end up being a 3rd degree polynomial. So my answer is 1x cubed minus 5x squared plus 5x to the 1st. And I really do have a plus 0 over x plus 1. But in this case, because those are zeros, I don't need to write them. So this is my final answer here. All right, so remember that from the remainder theorem, we now know that this x plus 1 is a factor of this quartic polynomial because we've shown that it has no remainder. So remember the significance of that when you're doing this division, because that may come into play in problems in the future. All right, so here we are going to apply that remainder theorem. We're going to determine whether or not x plus 1 is a factor of f of x, and then we've been given the equation of f of x. So I'm going to quickly set this up. All right, remember, negate that b value, that goes there, and all these coefficients. Don't forget, you're missing an x to the 4th term, and you're missing an x to the 1st term, so those places are held with zeros. All right, now we can rip through this pretty quickly by now. -1 comes down, we multiply, we add, we multiply, we add, we multiply, we add, multiply, add, multiply, add. All right, so now I could put in all my coefficients here, but I really don't care so much what they are, right? I know that because I divided a 5th degree by a linear, this is going to be my x to the 4th and my x to the 3rd and so on, right? Doesn't really matter, because the question that was asked is x plus 1 a factor of f of x? And we've shown that with synthetic division, which is very, very fast compared to long division, this 0 tells us that x plus 1 is a factor. And we know that from our lesson that we did in class. So before we start class on Friday, what I'm going to do is let you do this one on your own. Is x a factor of the function that's defined below? And this is the last part of the front of the notes. Hopefully we'll just practice in class. Think about this x, and if you did have to make it into a binomial, what would that binomial be? Right, because here we asked, determine whether or not x plus 1 is a factor, and that was easy enough because we could just negate that 1 and put it there. But what will we be negating here to use outside our synthetic division? Think about that, and then go ahead and answer this question before you come into class.